So we're going to quickly whiz through the water cycle and then talk about its implications. So you should be fairly comfortable that water underneath the hot sun, or in this country the fairly not hot sun, will evaporate. And as it does, it gets sort of held in the air, okay? So it's now being sort of water vapor within the air. It will then condensate and eventually precipitate. So the water that is held in the air will come together to form clouds, which will either basically fall as snow, rain, hail, sleet, whatever other types of precipitation you want to know. And it will then fall down to the ground, where it can be taken up by plants or fall into the groundwater, so sort of areas underground where the water is stored, or it will run off into rivers, streams, and eventually enter the ocean, where it can be evaporated again, and it goes round and round, thus the water cycle. But that's not what we're talking about today, realistically. I'm not going to re-explain the water cycle to you, where you should have probably heard it a million times. What we're going to talk about here is actually this. Only 3% of the fresh water in the world is fresh water. 2% of that is frozen and underground, and realistically that leaves about 1% that we can go and access, of which some of it's going to be used for industry, sort of recreation, sort of clothes, sort of making clothes and other things like that. So basically, there's not a lot of water, and we're polluting it by the second. So water is becoming a scarcer and scarcer commodity. And how do we make more fresh water then? How do we make fresh water from all that lovely salt water that we've got? So 97% of the world is salt water. There's one way we can do it. And you should hopefully realise that this is basically distillation. What you do is called desalination. De meaning undo or get rid of, or the opposite, and then salination meaning salt. So you're getting rid of the salt. And what you do is you provide a hell of a lot of heat, and you will drive off the water and evaporate it. So water in a gas form, also known as water vapor or steam. And then imagine, just if in terms of chemistry, you've got like a Liebig condenser here to cool all that air down. You just have a massive one in desalination factory, and then the fresh water comes out and condensates with no salt in it. Look at that, no salt. Problem with this is you need an enormous amount of heat, and that is terrible for the environment. So you need to think about how you're going to make this heat. So it's all well and good making water for everyone, but it's going to be enormously expensive. You do see this happening over the world, where there is not a lot of water. It doesn't rain massively, so you have to desalinate, but it takes a lot of energy. And the other thing you do is what's known as reverse osmosis. So ignore everything for a second here. So ignore that for a second here. So if we think about what would happen in osmosis, is just from what we know, actually, if you left this has got salt, and so this has got salt and other things within it. This has got a nice low water potential or water concentration. That's the symbol for it. What you'd expect to happen is water to move from its very high water potential or high water concentration, and it should go through this barrier. That is not what we do here. If you were to leave it with no pressure, that is what would happen. What certain companies and certain factories can do is they can put all this contaminated water with salt and bacteria and other things within it, and then put a semi-permeable membrane that only water can pass through. Only water can pass through. And if you apply loads of pressure, literally like physically put that water under pressure like a really powerful hose pipe or a jet, so a jet of water, and force it through the semi-permeable membrane that only the water can fit through, you will basically this will act as a massive sieve, and only water will get through. So this is known as reverse osmosis, because the water is moving the way that you shouldn't expect it to. Okay, so you should expect water to go from fresh water to water with stuff dissolved in it, but with this pressure that we have, by like pushing this water through it, we end up getting some fresh water going the other way.